Determine if the sequence converges or diverges. If it converges, determine its limit. So in these questions, all we have to do is determine the limit. That means what happens when n is really big. Limit n going to infinity of this general term of the sequence, all over 3n to the fifth minus 3n squared minus 5. And from calculus 1, we know that this limit depends on just the limit of leading terms because n is approaching to infinity. So leading term is n squared. So this is leading term here. Okay, so this limit is same as limit n going to infinity of 5n squared over 3n to the fifth. Now we can simplify. 2 copies cancel, 3 copies left, and when n goes to infinity, this is 5 over 3 times infinity. That means really big on the bottom. 5 over really big means 0. Okay, that means this sequence converges and the limit is 0. So the sequence converges to 0. In the same way, we can find for second question here. So limit of this general term is just the limit of leading term. So this one is leading. Leading means dominating term. That means highest exponent. So this limit is same as 3n to the fourth over 8n to the fourth. Oh, they are n4 cancel, 3 over 8. That means this sequence converges and the limit is 3 over 8. So eventually the terms on this sequence will go to 3 over 8. The sequence converges to 3 over 8. And same thing for the third part. Just find the limit. So limit will be limit of leading terms because we got a ratio. And if we think x, this is a polynomial, so 2n cubed and 1500 n squared. Okay, 2n cubed 1500 n squared. Now we can cancel 2 copies, 1 copy left. Though the number on the bottom is 1500, so this one is now, let me write one more step, not needed though, 2n over 1500, n going to infinity. That infinity is so big, still infinity on, even if we divide by 1500, still very big, so that's infinity. All that means the terms on this sequence are increasing without bound and they eventually go to become very, very big, infinity. So sequence diverges. Sequence diverges, okay, because it did not go to, the limit is not a finite number, final.